how do devices communicate inside networks? And how do companies organize thousands of devices efficiently? Well, the answer to that massive logistical puzzle is IPv4 and VLANing. Welcome to The Explainer. Today we're breaking down the absolute building blocks of modern computer networking.
If you've ever wondered what actually goes on behind the scenes when you plug in an Ethernet cable or connect to Wi-Fi, you're in exactly the right place. Because IPv4 and VLANing are the absolute foundation of how data moves around our digital world.
Here's our roadmap for today. We'll start with the basics of IPv4, look at IPv4 structure and types, and then explore organizing with VLANs. Finally, we'll dive into VLAN mechanics and ports and see IPv4 and VLANs combined. Okay, let's kick things off with Section 1, the basics of IPv4. Think of it like this. Just like your house needs a unique mailing address to receive letters, every single device on a network needs a unique IPv4 address to communicate. Whether we're talking about your smartphone, your laptop, or some massive corporate server, IPv4 is the protocol that gives it an identity. Without it, the network wouldn't have a clue where to send your data, and you literally wouldn't be able to load a single web page. Now, this entire addressing system is built on what's called a 32-bit architecture. That just means under the hood, the addresses are powered by 32 ones and zeros. And that math provides over 4.2 billion unique possible addresses. I know, that sounds like an infinite amount, but fun fact, with the absolute explosion of smartphones and smart devices, the world has actually run out of these public addresses. So how does a computer actually make sense of all those numbers? Let's find out in Section 2, IPv4 structure and types. Here is a classic example of an IPv4 address that you might actually recognize, 192.168.1.10. If you've ever poked around your Wi-Fi settings at home, you've almost certainly seen something very similar to this exact sequence. So what's going on here? That simple set of numbers is structured into 4 sectors we call octets, separated by dots. Because of that 32-bit math we mentioned, each octet can only be a number between 0 and 255. And while we see those nice readable decimal numbers, your computer actually processes them as a long string of binary ones and zeros. Oh, and then there's the subnet mask. You can think of the subnet mask kind of like a neighborhood border patrol. It's a simple way to mathematically split the IP address into 2 parts, a network portion, which is basically your street name, and a host portion, which is your exact house number. To keep everything secure and organized, the internet uses 2 main types of these addresses. First up, public IP addresses. These are assigned by your internet service provider, and they act as your public face to the wide-open internet. Second, we have private IP addresses. These are used strictly inside local networks, like your home or your office building. Private IPs are safely hidden away behind a router, ensuring your personal devices are never directly exposed to the outside world. Moving right along to Section 3, organizing with VLANs. Here's a question for you. What happens when you have thousands of private IPs in one massive corporate building? Without VLANs, all those devices share one chaotic network. Imagine a massive room where thousands of people are all trying to shout to each other at the exact same time. In networking, that crowded room is called a single broadcast domain, and it causes immense congestion and serious security risks. But VLANs, or virtual local area networks, solve this. They allow us to logically slice up the network. You take one physical switch and virtually divide it into multiple completely isolated rooms without having to buy extra physical equipment. And to keep everything perfectly separated, each VLAN is assigned a unique ID. These range from 1 all the way up to 4094. That gives network administrators an incredible amount of room to organize even the largest companies. Now, depending on what kind of traffic is flowing, network engineers will utilize specific types of VLANs to keep order. Everything usually starts on a default VLAN, which is typically VLAN 1. From there, data VLANs handle your everyday emails and web browsing. But what if someone's on a crucial internet phone call? We put that on a voice VLAN so the audio doesn't drop. IT admins even get their own VIP lane, the management VLAN, so they can configure the network securely. It's just a brilliant way to keep different types of digital traffic in their own dedicated lanes. Let's dig a little deeper into how this actually works in Section 4, VLAN mechanics and ports. So how do physical switches handle all this logical traffic? Well, it all comes down to the ports. First, we have access ports. Your everyday office computer plugs into an access port, which is locked to one single VLAN. Honestly, your computer is completely unaware of the VLAN, it just sends data as usual. Then we have trunk ports. These are the heavy-duty connections linking different switches together, and they carry traffic for dozens of VLANs simultaneously. To keep it all straight, trunk ports use a standard called IEEE 802.1q. Think of it like a digital shipping label. It places a specific tag on the data to identify exactly which VLAN ID it belongs to, so nothing gets mixed up in transit. And this strict separation brilliantly illustrates the security of VLANs. Devices in different VLANs absolutely cannot communicate directly. No way. If a computer in VLAN 10 tries to talk to a computer in VLAN 20, the switch just drops the request. Instead, the data must be routed up to a layer 3 switch or a router. That router acts as a strict security checkpoint, performing what's called Inter-VLAN routing. It explicitly verifies the data and grants permission for it to safely cross over to the other department. Finally, let's bring it all together in Section 5, IPv4 and VLANs combined. Let's look at a really practical example of how the micro and the macro combine. A great network design pairs a department's dedicated VLAN ID perfectly with its very own unique IPv4 subnet. For instance, human resources is logically grouped into VLAN 10 using the 192.168.10 network. Finance gets VLAN 20 using the .20 network, and IT gets VLAN 30 with the .30 network. By aligning the IP addressing directly with the VLAN numbering, we create a structured, highly organized, and easily manageable company network. So, the big takeaway here is that combining careful IPv4 subnet planning with VLAN segmentation results in an incredibly robust network. This separation completely isolates sensitive departments, like finance, which vastly boosts your security. It heavily reduces that chaotic broadcast traffic we talked about earlier, leading to much faster performance. Plus, it offers amazing flexibility. Someone from HR can sit on an entirely different floor, plug into an HR-configured port, and securely join VLAN 10 as if they were sitting right next to their team. Mastering IPv4 and VLANing is absolutely a key step toward becoming skilled in networking. By understanding these two foundational concepts, you now hold the blueprint for how the world's largest companies maintain order, security, and speed in an absolute sea of digital traffic. But here's a final thought to leave you with. If we've already exhausted all 4.2 billion public IPv4 addresses globally, how are new devices connecting right this second, and what exactly does the future of IP addressing look like? Well, that is a fantastic topic for another explainer. Thank you so much for watching. If this explainer helped you understand IPv4 and VLANing, please like it, subscribe to the channel, and turn on notifications for more simple networking lessons. Catch you next time.